Hello there, and welcome back to your second lesson for the week. If you remember, in our last lesson, we did midpoint and the distance formula. So we are going to be applying some of that stuff to today's lesson. We're going to be building on those skills. So in this warm-up that you are looking at, I think it would be an awesome idea if you wanted to pause the video at this point and try it on your own or see what you could do, or even just coming up with a method to solve this. Keep in mind that you do have access to this presentation and the guided notes. So if you're able to print it out and follow along, that is fantastic. If not, no worries. You can still follow along as I go through this. So in this, we are asked to find the length of AB, BC, and CA. And if you see, we have over here, we've got actually triangle ABC, right? So we are finding essentially the lengths that form that triangle, like the side lengths. So there was a few different ways we could do this, and we talked about in the last lesson the distance formula. And we also talked about just using the Pythagorean theorem. And the reality of it is that they're the same, right? The distance formula is coming from the Pythagorean theorem. They are the same. So it doesn't really matter which one you per se use, whatever makes you happier, but they are the same. So the Pythagorean theorem, if you remember, was a squared plus b squared equals c squared. And then the distance formula was the square root of the change of x, so x2 minus x1 squared, right? Oh, that's like a squared, plus y2 minus y1 squared. Oh, that's like b squared, right? And then you're taking the square root of it. So that is what the distance formula was. So we're going to be applying that over here. And I think what I'm going to choose to do is I'm going to use the Pythagorean theorem because I have a picture. So I'm going to first choose to focus in. That is not a color that's going to work for us, is it? I'm going to find the length of AB first. So I'm going to kind of create this right triangle right here and then work through that. So I'll use these different colors. 1, 2, 3, 4, 5, 6, 7, 8. So that length is 8. This length right here is 2. So to figure out the length of AB, I'm going to be doing, I need a little bit of room over here. Tiny. What? There we go. So AB, I'm going to choose to do 8 squared plus 2 squared is going to equal to 64 plus 4. So that is going to be the square root of 68. And for the moment, I'm going to leave it like that. I'll simplify them all at the end. Great. Okay, now I'm going to focus in on finding AC. Let's see, should I use a highlighter again? So I'm going to form that into a right triangle. This length right here, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this length right here is 2. So to find AC, I'm going to do 9 squared plus 2 squared, which is 81 plus 4, which is 85. And then for Pythagorean theorem, that last step is going to be the square root. So that is AC. So this is the square root of 85. And then for that last side, shall I use this color? Yeah. BC. I'm going to form that. That's not an effective triangle. It's like way too large. Into a right triangle. And let's see, what are the side lengths? 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8. So that's BC, and that's going to be 8 squared plus 2 squared, 64 plus 4, which is 68, and then I would take the square root of that. If you are someone that is a big rounding fan, that's fine. So the square root of 68, I'm going to choose to round it to about 8.246, I'll go with. That's fun. The square root. Oh, that is. Are these the same? Oh, yeah, they are. Right? So we just did that. 8.246. And then this last one, the square root of 85, is approximately 9.22 is what I'm going to go with. So this is awesome, right? What is that actually? And we can even extend upon this. So we had triangle ABC. What type of triangle is triangle ABC? Right? Because we know that AB and what's this other one? BC are the same length. So it's is isosceles. That's so cool. Right, so then even more than that, and I'm just really extending now, this angle right here and this angle right here, so angle BAC or angle A is actually going to be congruent to angle C by the isosceles triangle theorem. Wow, this really ties a lot of stuff in. So not necessarily the direction I was going with it, but we now have the length of all three sides of the triangle. What might we do with that? What could you do? What is it called if you were to add these all together? Right? If I were to add the length of AB, right? Let's say I start and I'm standing here and I walk and I'm walking and I go to B and then I turn and I walk and I go to C, right? So I walked the length of AB, I walked the length of BC, and then I'm walking the length from C to A. What is that called? Oh, if we add them all up, if we add 8.246 plus 8.246 plus 9.22, we get 25.712 units, which is actually more accurately known to us as the perimeter of this triangle. Right, so we are going to be building today, or in this lesson, maybe it's the same day for you, on what we already know about finding length and working with shapes, different 2D shapes on a coordinate grid to determine some important information that we want. So to restate that, we're going to be using coordinates to compute perimeters. We almost just did that. And areas of polygons, right? So of closed 2D shapes. That's what a polygon is. Such as a triangle, of a rectangle. I mean, we could be working with a trapezoid. We could be working with, we could really be working with a, no, I won't say we're doing a circle. What other shapes did we have? We could just have a quadrilateral. Right? It doesn't have to be a regular figure. So think about maybe some of the formulas that you might remember for area. Right? So think about that, because I'm going to ask about that in just a moment. So area and perimeter. So area is the space a 2D shape takes up. Right? So it's the inside. Right? It's how much space does it take up. So that is like it's like floor space, right? So like you could think of it as floor space. I encourage you, sorry I didn't start with this, but maybe write this down. This is where your notes pick up and what you can start to write in and fill in on your paper if you were able to print it out. So the space a 2D shape takes up, it's the inside, it's like the floor space. I would say it's probably important for us to remember that it's units squared, right? Whether it's squared feet, squared miles, squared meters, squared kilometers, squared centimeters, any of that, but it's the units squared, right? What are some formulas that you remember? Maybe write them down and see what you remember. What about a rectangle? Area was just base times height. What about a triangle? Area was base times height divided by 2. What about a trapezoid? Ooh, now I'm going to go off the paper. Area is base 1 plus base 2 divided by 2 times height, right? A trapezoid had 2 bases, so you were averaging the 2 bases and then multiplying it by the height, which was the distance between those 2 bases. I'm just going to do one more. What about a circle? Oh, area was pi r squared, right? You have these formulas. You do have a formula sheet, or you have the, like, you don't have to have these formulas memorized. You just need to know how to use them. Perimeter, right? So perimeter is the length, or I'm going to say distance, around a shape, right? So this is just going to be in units, right? Like this could be centimeters, inches. It's not squared, right? It's one dimensional. So it's just a length. So maybe I should say that. This is one dimensional and this is 2 dimensional. Area is 2D. Volume is 3D. That's a D. Nobody's going to know that later. But you can't even raise your hand and say, hey, what does that say? To find the perimeter, you would find, there's not really always a formula, so I didn't ask you what are some formulas for perimeter. Find the length of each side and add. So we're going to start with area because perimeter ties in. I mean, we just did it on the warm-up. Perimeter is a lot more closely linked to what we did in the last topic. So I want to start with the piece of it that's very new to us, the area aspect, and then we will close out with perimeter and do a check-in at the end. So follow along. So here's the 2 examples that we're going to start with. So there we go. So we're going to find the area and the perimeter of these shapes. So I'm going to start by, and I'm going to try to do this as neatly as possible. I'm going to actually write the coordinate points on here. So this right here is -7, 5. This here is 5, -4. This is -7, -1, 2, 3, 4, -4. And this is a right triangle, right? This here is a right angle. If I really wanted to find the slopes and show that they're perpendicular, I even could, right? This one's 0, this one's undefined. They form a right angle. So I want to know the length of, I know how to find the area of a triangle, and I'm going to start with area down here, right? The area is base times height divided by 2. The base and the height form that right angle. So what is the length of this? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, I think. That makes sense. -7 to 5. What about here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it's got to be 9. That's a 6. That's where my error is. That's 10. So that's my base and my height. So I'm going to say it's 10 times 12 divided by 2. That's 120 divided by 2. So it's 60 units squared. What about the perimeter, right? We said we had to find each length and add it up. Well, I've got 10, I've got 12, and I've got, oh, what is that third length? Well, how do we find it? Distance formula, or here I'm looking at I can just use the Pythagorean theorem. 10 squared plus 12 squared equals, I'll say c squared is the hypotenuse. So 100 plus 144 equals c squared. 244 equals c squared. So the square root of that is going to give me that last length, that length of c. So the square root of 244 is 15.62 approximately, is c. So that's what I'm going to add, 15.62. And when I add these up, 10 plus 12 plus 15.62, which this length right here is 15.62. It's equals to 37.62 units squared. Oh no, just units, right? It's just a length. Right, so it's kind of taking some of your prior knowledge and just sticking on a coordinate grid. Let's take a look over here at this rectangle. All right, so let's see. Let's count. Let's write the coordinate points in. This is going to be 4, 5, 6, 7, 8, 4, 8. This is going to be -6, 8. This is right, so I can see this is clearly a right angle. I got 4 right angles. This right here is -6, -2, and this here is 4. Oh no, it's not. It's -3, isn't it? -3. So let's write in the lengths as well. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is also 10. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11? 12? No, 11. And this is 11. So, you know what? Let's just do the perimeter. I've got them all, don't I? So all I got to do is add 10 plus 10 plus 11 plus 11. So this is 42, and it's just a length, so 42 units. What about the area? Well, it's a rectangle, so area is base times height, right? The base and the height are perpendicular. You're just multiplying the 2 dimensions. So 10 times 11 is 110 units squared. So that literally means there's 110 little boxes in here. That's literally what area is. Fantastic. So take a look at this, make sure you followed along with it and that you understand where we're going with this. And then see that it's really just something you have studied in the past, but we're sticking on a coordinate grid. Awesome. What happens here? Right? I know it's a triangle. I know that I have this triangle ABC, but I don't, what? I mean, I guess I can find the length of each side. I'm fine with perimeter. Perimeter we might be good with, but what about area? This is just asking me for the area. It's not even saying perimeter. Huh. Right? I know base times height divided by 2, but like what's the base? What's the height? I don't see anything that's perpendicular. Base and height must be perpendicular. Right? So I'm going to give you a few steps for success when you don't see something that you can nicely find the area of, like the 2 we did on the last slide. So the first thing that I'm going to do is I'm going to draw a box around the figure. So I'm going to literally form this into a box. So I'm going to go, I'm going to turn here because I want to hit B. I want my 3 vertices to be on the perimeter of my box. Fantastic. So I'm done with step 1. Step 2, I'm going to find the area of that box. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So that's a length of 8. This is a length of 1, 2, 3, 4, 5, 6. So I'm going to find the area of that by doing 8 times 6. So the area of my box is 48 units cubed. Oh, no, not units cubed, units squared. Caught myself there, it's area. Right, so that's this whole thing. I don't want this whole thing, right? I need some things to go away. So my next step is going to be to find the area of these pieces. So I'm going to call them 1. I'm going to call this one 2, in no particular order. I'm going to call this one 3. And then I'm going to call this one 4. I used Roman numerals, doesn't really matter. So these pieces, in this case, are actually triangles. They're actually right triangles. So let's go ahead and let's do 1. Area is going to be 1, 2, 3. So this little part's 3, and that's 8. So I'm going to do 3 times 8 divided by 2. 3 times 8 is 24 divided by 2. That one's 12 units squared. Let's go ahead and let's do number 2. This one's 1, 2, 3, 4. This is 3. So the area is going to be 4 times 3 divided by 2. So that's 12 divided by 2, which is 6 units squared. In my last one, I'm going to do 3. So let's see, 1, 2, 3, 4. And this whole thing is 6. I've already counted that. So the area is going to be 6 times 4 divided by 2. 24 divided by 2, which is 12 units squared. So I have now those 3 areas. I know the area of the whole thing, and I know the area of 1, 2, 3, right? So how can we now go about figuring out the area of this orange region, which I referred to as 4? Well, in my next step, I'm going to add the area of those 3 pieces. I'm going to add 1 plus 2 plus 3. Right, so that's going to mean I'm going to add 12 plus 6 plus 12 again. 12 plus 6 plus 12 again. So that's going to give me 30 units squared. So the whole thing was 48. These parts that aren't in my shaded region are 30. So how do you figure out your shaded region? Subtract step 4 from. Step 2, that's a typo. Darn. Right, so I'm going to go ahead and I'm going to say, well, 48 minus 30, so the entire thing minus the parts that aren't in the shaded region, I'm left with 18 units squared. So this is the method that you are going to want to use when it's not a shape you can easily find the area of. Even though this is a triangle, I didn't know what the base and the height were, right? I don't know the 2 parts that are perpendicular. So instead of trying to figure the height out and trying to do all of that, I'm going to use what I do know. And we had done work with finding area and finding composite area, an area of the shaded region. So that's what this is, right? I'm finding the area of the larger piece. I did that by making sure the vertices were all on that box that I drew. So we're going to refer to this for the remainder of this lesson as the box method. And we're going to practice using the box method right now. So I would really encourage you guys to pause the video and try these 2 on your own, and then unpause it and check your work. So label the quadrilaterals with the given vertices, then determine the area using the method above. So using that box method. So let's see. -1, 4, this is H. So I'm done with H. G, -4, 4, this is G. I is -6, -5. And then 1, -5 is J. So we're going to be finding this area. So I'm going to go ahead and I'm going to draw a box that connects every vertex. And yes, there is another method. You don't have to use the box method for this. But I want to practice it. Okay, so here's the box. Let's find the area of the box. So let's see, this length is -1. I'm sorry, I don't know why I said negative. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 2, 3, 4, 5, 6, 7. So 9 times 7 is going to be 63 units squared. So I have, if I shade in the part that I want, I have two things that I'm going to be subtracting. Right? This is split. I really have three parts going on here. That was almost good. So I will call this 1. I will call this 2. So if I'm going to find the area of 1, this is 2 and this is 9, right? We already know that. Yep. So 2 times 9 divided by 2, 18 divided by 2. So that area is going to be 9 units squared. And then if I'm going to find the area of the other one, this is 9 and this is 2 also, right? Same thing. So 9 times 2 divided by 2, 18 divided by 2, which is 9 units squared. I'm going to add them together. 9 plus 9 gives us 18. And in my 18 units squared. So that's the area of 1 and 2 together. So I'm going to be doing the entire box minus 18. Gives us 45. Right? Not the only right way to do this. Maybe you went into this and you recognized that you can use the formula base 1 plus base 2 divided by 2 times height. Right? Maybe you recognize that you could just split this up into shapes you knew. Fine. Those are all fabulous ideas, and I encourage you to try them. I just want to show you this method. That's really where I'm going with this. So here, I'm going to do the same thing and label them. So 2, 6, this must be C. This must be 5, 3, so this is D. This is 2, 0, so this is A. And then this is -1, 3, so this is B. Same thing. I'm going to go ahead and do the box. Okay, so let's see. 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5. Oh, 6 and 6. That's a square. So that box is 6 times 6, so it's 36 units squared. And let's see. 1, 2, 3, 4. This is 3 by 1, 3 by 3. This is also 3 by 3. This is also 3 by 3. This is also 3 by 3, right? Those triangles all have the same thing, right? So to find the area of all of them, of 1, of 2, of 3, and of 4, I'm going to be doing 3 times 3 divided by 2. Right, so that's going to give us 9. I don't know why I wrote divided by 9. Divided by 2, which is 4.5. And then there's 4 of them. So let's go ahead and 4.5 times 4 is 18. And then our last step is to just do 36 minus 18, which is going to be 18 units squared for that area of this shaded region of what's left over. So of all of this, maybe you thought of another way of how to split this up. Right? Maybe you thought, and maybe you want to try it right now. You wanted to do, what if I connected these? And I connected these. And I just found the area of each one of these triangles. Or I just found the area of these 2 triangles. That's a great idea as well. And I would love for you to try it and see if you get the same answer. Any method is perfectly acceptable as long as it's leading you to this solution. So let's transition a little bit now that we've looked at some different ways to find area on a grid to finding perimeter. Let's transition back to this. So my first question for you with this is, which lengths can you find easily and why? And maybe what do I mean by easily? Right? I really mean with no real math. Right? Or no arithmetic. So I'm referring, and maybe this is where your head went, BA and CD, right? Because they're both vertical. So you just count, right? I know that BA has a length of 1, 2, 3, 4, 5. And I know that CD has a length of 1, 2, 3, 4, 5, 6, 7. And I really didn't have to do any arithmetic. It was just counting. And so that's what I mean by what can I find easily. What can you do to find the other lengths? So what kind of math is involved in me finding BC and in me finding AD? You can do the distance formula. And this is stemming right from that warm-up and then what we did in the last lesson. Or the Pythagorean theorem. And let's go ahead and let's actually do that, right? So to find BC, let's think about the triangle that's created. Here's that nice, it's pretty narrow triangle. So this has a length of 1, this has a length of 1, 2, 3, 4, 5. So I should do 5 squared plus 1 squared, square root of that. Square root of 26, which I'll say is about, you know what, I'm not even gonna round that yet. I'll come back to that. What about this one right here, AD? Let's make it into a triangle. I tend to make the triangles on the outside. I could make them on the inside. It won't matter at all. Right, and there was the right angle. So this has a length of 1, 2, 3, 4, 5. This has a length of 1, 2, 3. So to find the length of, what was that? AD, I'm going to go ahead and do the square root of 5 squared plus 3 squared, which is 25 plus 9, which is going to be 34. So to calculate the perimeter, that's what we're just going to add, right? So we've got 5 plus 7 plus the square root of 26 plus the square root of 34. So this is going to give us 12 plus, what is the square root of 26? 5.1 plus the square root of 34, 5.83. So 12 plus 5.1 plus 5.83 gives us 22.93 units. Not a fan of how I wrote that, units, because it's just a length. It's a distance around the shape. You pick a point, you go directly around it, and you end up at that same point. So maybe try these, right? Maybe pause the video and try these. We did one like this in a warm-up, and we've done a few. Like maybe you can do it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, so I know 5 and 5, and then let's go ahead and I'm going to make, I like doing a triangle. 1, 2, 3. 1, 2, 3, 4. So to find that length, oh no, I need to label it. What is this? This is going to be B, and this one's going to be, so -6, 3 is A, -6, -2 is D, and this is -2, -5 is C. So to find the length of AB, I'm going to do the square root of 3 squared plus 4 squared. So that's the square root of 9 plus 16. Square root of 25, which is, oh, look at that, 5. So this has a length of 5. And then this last one, if I'm going to find the length of DC, 1, 2, 3, 4. 1, 2, 3. Oh, didn't I do that? I feel like I did, right? The square root of 3 squared plus 4 squared is the square root of 25, which is also 5. Oh my gosh, 4 congruent sides. What does that mean? How cool, this is a rhombus. Right? It would either be a rhombus or a square. I can clearly tell that these are not right angles. Their slopes are not opposite reciprocals if I wanted to find them out. So to find the perimeter, I would do 5 plus 5 plus 5 plus 5, or 5 times 4. So I'm going to get 20 units. What about over here? So I know 1, 2, 3, 4. And I know 1, 2, 3, 4, 5, 6, 7, 8. I don't know those two, but I forgot to label them again. 2, 4 is B. 4, 0 is C. Negative 4, 0 is D. And negative 2, 4 is A. So I'm going to find the length of AD first. So here's my triangle, 1, 2, 3, 4, and 2. So to find AD, I got the square root of 4 squared plus 2 squared. So I'm just writing in the square root symbol first because I know in Pythagorean theorem the last step is the square root. 16 and 4, so it's the square root of 20. And what about this one over here? I'll round that soon. Not yet. 1, 2, 3, 4, and 1, 2. Oh, isn't that the same? BC again. Square root of 4 squared plus 2 squared is the square root of 20 also. So if I'm going to find the area, I'm sorry, the perimeter, wow. 8 plus 4 plus root 20 plus root 20. Right, so this is 12 plus, and the square root of 20 is about 4.472. So 4.4, so 20 plus 4.472 plus 4.472 is approximately 28.944 units. Oh no, I don't know why I keep doing that. My mind is jumping back and forth between area and perimeter. Learn from my errors. Great. So, if you have not tried any on your own, I want you to treat this like an exit check. Right? So like pretend that you were in class, we just did this lesson, and then here is your exit slip to check for your understanding. And I'm giving you this picture, and I want you to find the perimeter, and I want you to find the area. So what I really love to happen is that you pause this video right now, and you try this as if this was a quiz, or if this was a check-in. So I'm going to go ahead and go over this and grade yourself as you do that. Right? So I'm going to start with the box. I think that's going to help me with everything right now. That's going to help with perimeter, because then I will have all these right triangles. And that's also going to help with area, because I have a triangle, but I don't know what I have that's perpendicular, or if I have anything that's perpendicular. So I've got my box. I'm going to write in these lengths that I have. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, that's 5. And this is 1, 2, 3. And I'm going to call this 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep. Okay. So let's see. That's 1. Let's do, I'll call this 2. So this is 1, 2, 3. And this is, well, you know what? I can tell really easily that this is 2. So that's going to mean that this has to be 11, right? If the whole thing across is 13, but I guess I'll check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. And then for that last one, which I'm going to refer to as 3, I have to write the number correctly. This is going to be, it should be 8, right? 5 and 2, but let's check. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to actually do perimeter first because I'm going to have to use the Pythagorean theorem for every single one, right? So to find the length of HG, I'm going to be doing the square root of 5 squared plus 13 squared. So that's the square root of 25 plus 169. So that's the square root of 194, which is approximately 13.928. And then I will do, I think that's a J, GJ next. The square root of 3 squared plus 11 squared is the square root of 9 plus 121, which is 130, which is approximately 11.402. And then my last side of my triangle is HJ, I believe, yes. And that is the square root of 8 squared plus 2 squared. 64 plus 4, it's the square root of 68. Scalene triangle. All 3 sides are different. 8.246. And then to actually find the perimeter, we're going to be doing 13.928 plus 11.402 plus 8.246. 13.928 plus 11.402 plus 8.246. And I got my answer to be 33.576 units. And the way I've set this up, I've now set myself up for success in the area. Oh, that's pretty funny. So I'm going to find the area of that box first, right? So the area of the box, remember the steps to success? I was going to try to do this so neatly. Pen, blue, box. The area of the box is going to be, so it's a 13 by 8 box, so 13 times 8 is 104 units squared. And then I'm going to find each one of those units, and remember what I'm going to do? Subtract. 5 times 13 divided by 2, 32.5 units squared. Where's number 2? 3 times 11 divided by 2. That's 33 divided by 2 is 16.5 units squared. And then number 3, the area of part 3, 8 times 2 divided by 2. So that's going to give me just 8, right? Those 2's will cancel. So if you recall, I'm then going to add them, right? So 32.5 plus 16.5 plus 8 gives me a total of 57 units squared. So in order to find the area of this shaded region, the actual triangle HGJ, or whatever we're calling it, I have to take the box and subtract the area of 1, 2, and 3, that empty space. So I'm going to take that 104 and I'm going to subtract that 57. And wow, look at this. And I'm going to get 47 units squared. If you've used a different method, again, just to reiterate, and you chose to try to split this up or find a height or just split this up into shapes you did know, right? Like maybe you drew a line here and I don't know. I'm not really sure, but maybe you found a different way to do this and that is totally acceptable if you did. But if you got these 2 answers, fantastic. If not, maybe see if you want to go back and rewatch any part of the video. I to get some more help or support with this. What we just accomplished in this lesson was building our ability to use coordinates to compute perimeters and areas of polygons of closed 2D shapes, such as triangles and rectangles, and kind of building on our already the knowledge that we already had about distance and about area and perimeter, and combining those pieces of algebra and geometry together. So I encourage you to use the extra support resources, the worksheets, the quizzes, the Delta Math, any online practice out there that has been put out to you in order to practice. And hopefully you enjoyed this video. Thanks for watching.